Let's take a look at what we've got. And like I said, it looks like everyone got number one. Actually, let's take a look. Okay, only one person didn't get number one, but hopefully you kind of noticed for this problem, right? We have 36 total coins. Excuse me. In grandma's coin purse. And here's the distribution, right, of the coins, okay? If she reaches into the purse and pulls out a random coin, what is the probability that the coin chosen will be? And the first question is a penny. And so a penny is about 11%, okay? How do you guys get 11% from this problem? How is that the answer?
There's only a few pennies.
As in?
There's only 4.
There's 4 out of 36 pennies.
Out of 36 altogether. 36 total coins.
Good. So if we were going to represent the probability as a fraction, what fraction would we use?
I might have a deal.
Mm-hmm. Anyone else can answer as well? 4 over 36, is that simplified? No. 1 over 9, good. So our fraction version, right? So grandma has a 1 in 9 chance of pulling out a penny from her coin purse. Okay, good. All right, looks like you guys did similarly. So nickels, it's just the same thing, right? But we're changing the numerator from 4 to 12. Now we have 12 out of 36. What does that simplify? 12 over 36 simplifies to 1/3.
That's nothing compared to the way I did it.
Okay, how did you do it?
Well, there's 20 dimes, and the highest percentage is 56, so I chose 56. And 12 nickels is kind of in the middle, so I chose 33%, and 11%, which is the lowest, so I chose the, what's that, penny?
Mhm.
Quarters was 9. That's it. I didn't even do no math on it.
Yeah.
Like that.
Did anyone else notice that? What did you guys hear Michael's observation? Did anyone else notice that? I did try to make it kind of easy-ish or obvious-ish. But good, right? So because let me see if I can, if we look at the question, right? So what Michael's saying, right, is that since they give us, right, the answers here, all you really have to look at is say, okay, well, if the fewest is pennies, then that means it would be the smallest percent, right? And nickels would be the middle percent and dimes would be the largest. And once again, since there's no quarters, it's 0. So yeah, so that's one of the things to kind of note is that, yeah, generally there's always the math, okay? But sometimes just logic and looking at the problem and digesting it logically can help you be efficient with that. So does everyone kind of see how that?
I did the same thing, but I was back and put it together problem anyways.
Okay, that's fine too. And that would be another good thing to do, right? Is like, you know, that's the answer, but then can you confirm it with the math? And that's another good reason, right, to know the math is just to make sure that if you were incorrect, but not so good. So then dime, same thing, right? We have 20 out of 36 dimes, which is about 56%. Okay. And then, like you guys said, it looks like almost everyone got this, and maybe you just didn't read it correctly. But of course, it is impossible, right? To select a quarter from grandma's coin purse because, right, there are no quarters in it. I guess she did her laundry or something earlier in the day. My grandma Hazel always collecting quarters to do her laundry. And sometimes the pop machine got some.
So you're right. Good times.
All right. Any questions about this first problem and the different pieces of the problem? And so, yeah, really nicely done on the logic side, and I'm glad you shared that, okay? All right, so then the next two problems are based on this data, okay? Did everyone make sure that you kind of applied this information to the two problems that related to it? So, sorry. So use the survey data below to answer the next two questions. So, right, we surveyed 1,000 people. Okay. And then here was, right, the results of the survey. Among the 1,000 people, right, we have a sense of their preferences. Now, hopefully you guys know this as well, right, that 1,000 is a really handy number for your survey because it's really easy to calculate the percentages, right? If I say 180 out of 1,000, can anyone tell me?
80%.
18%. Good. How are you figuring that out, Michael? You just super smart. Okay, good. Right?
The 1,000, that's why if it was
Mhm.
like 1,500, it would be a little tricky.
Yeah.
I think we was like, well,
Yeah, well, any percent, right? And same with our percentages, right? We're always doing it out of 100. So any other number that's similar, right, with zeros, like 1,000, 10,000, 10, right? It's easy to work with those numbers. And so what you're really doing is, and I can't remember if we talked about this in the summer or not, but yeah. You put like 180 over 1,000. The first thing that you can always do to begin to simplify a fraction like this is shave off your zeros. So right away now I've got 18 over 100. And remember, you can think of 100 as the whole, right? And 18 as the part. So if you have 18 over 100, that's 18%. Okay, right? 18 parts out of 100. So very nice. Okay. So hopefully everyone caught that. So the thing to know is the other application, or probably actually the most common application of probability, is to help us when we're collecting data and trying to kind of figure out something about a group of people. And so if we have, so we can kind of think about our survey, our first survey here as kind of our, what we would call preliminary data, right? So this is kind of our first round of surveying people, but, right, since we surveyed enough people and we kind of already know what to expect, right? The next 1,000 people, if it's like they're all from the same group, would probably have almost the same preferences. Does that make sense? So maybe
A little bit.
a little bit. So if we look at the first question, it tells us how likely is it that the next individual surveyed, or sorry, the next person surveyed will prefer pancakes. And we're basing it on our data from here. So we know that 250.
It's 25%.
Mm-hmm. Exactly. Good. And so, yeah, so basically we're just applying what we learned from our first 1,000 responses to our survey. And so, yes, so we would say it is about, right, a 25% chance that the next person surveyed would prefer pancakes, right? 18% chance they prefer bacon and eggs, or eggs and bacon, I guess. 38% cereal, right? 19% is, I don't know, protein bars and smoothies. What else? Oh, what, I don't know if oatmeal goes with cereal. See, this is why I can't do surveys.
No, but I like cream of wheat. If anybody still eats that anymore.
Yeah, I have not currently or consistently eaten it. But I grew up in a grit house. By the way.
Good food. Yeah. Every time my brother would go over to visit my grandpa, he always had grits. That's like what he would eat when he was traveling.
Good, so hopefully that makes sense, the logic here. So we're just saying that because we already know from our first survey that 25% of the people preferred pancakes, then we know that the next person we survey, it's about a 25%, right, chance that they will prefer pancakes. Now, they might not, right, and that's fine, right? It's unlikely that they'll prefer pancakes. But actually, none of the preference choices really are likely. So I guess that means people have a diverse breakfast preference. I'm just anything that's already there and ready to go, I'm gonna eat it. If I have to make it, that might be a different story.
Like you're fine.
I know, I'm like, oh, you wanna make me pancakes? Well, then hell yeah, I'm gonna eat pancakes. I would never make pancakes for myself. I'm a weird person who likes pancake batter. What do we make it?
Yeah, I can agree with you on that. I will agree with that.
Oh, I'm so glad there's another.
I will agree with that.
Pancake batter with me. All right, so now we're gonna do the same thing. We're gonna take our data and our results from our survey and apply it to kind of the next group of people we're gonna ask. So we know that cereal in our survey, right, we got 380,000, or sorry, 380, goodness gracious, 380 out of 1,000, sorry, preferred cereal, which is 38%, okay? And so now we have to go back even one unit further, and so basically, since we know that from our first survey, 38% preferred cereal for breakfast. All we have to figure out is, right?
38%.
38% of 200.
Or 200 about
which is
76.
76. Good. And so once again, I was trying to be a little tricky and put some percents in there. Hopefully you eliminated those right away because, right, we don't count people as things, not percents. So good. So hopefully you guys remember if we know the percent times the whole, that gives us the part. Okay, so good. So if you see, you'll probably see problems like this where they'll give you data, you're going to use those percentages and apply that to, you're basically using it, right, to predict what the next group is going to look like based on the data that you first collected, okay? Everyone on Zoom feeling good about this stuff? Any questions or problems? Am I going too fast or slow? Hopefully you guys are feeling okay. Good, thanks, George. No, you're fine. That was good. All right. Hi, Kayla. Welcome. Okay, next question. All right, so these were our simple probabilities, right? Where we're basically, well, I guess number one, those four were simple probabilities. We would probably say number 2 and 3 are kind of our probability applications, where we're using data to create probabilities to predict what the future might look like. or what other opinions might be. And then here we have our compound probability, and hopefully you guys noticed, I didn't do any highlighting here. Oops, now I gave the answer away. Let's do that. I'm excited. So here, if the Wix company usually completes, 30% of their projects early. Okay, so once again, we already kind of have some preset data. Okay, what is the likelihood of them finishing their next 2 projects? Typo, early. Okay, so we have 2 events. Okay, right? We have completing project 1 early and completing project 2 early. What do we do?
I don't know. That's why I got it wrong.
Okay. That's okay. So yeah, and this one is a little tricky, but okay. So we know that, whoa, sorry, that's not good. There we go. Anyone on Zoom got any ideas? Michael, is this the one you missed too?
Oh, I got it right.
You got it right? Would you mind sharing what you did to get it right?
Well, how to explain it?
Okay.
I just thought 30% next day would be like 16%. I thought they're gonna take another days, but like it's gotta be lower.
Okay.
Lowest one was 9%, but it's still.
I like it. Good, and so hopefully, yeah, there is some good logic there. Thank you for sharing. Yeah, right, so hopefully we remember, right, that when we have compound probability, right, then that means that it's generally gonna be unlikely, right? So we wanna kind of look at the lowest numbers. And so hopefully you remember to do a compound probability. And I'm just gonna abbreviate this, right?
Like you could take the test by just guessing and getting all right anyways.
It's possible. I mean, that really should be the starting point unless you feel like immediately, like you know what kind of calculations.
I wouldn't do it.
What do you mean?
I only guess on it.
Oh, yeah.
You guess a majority of them, I would say you have a pretty good chance.
I did it.
Yeah.
My driver's license 9 times.
Okay.
I guessed all 8 times. The last time.
You studied? Okay. Yeah. And I mean, like, some people just aren't good at multiple choice either, but that's good to know. Yeah. Like if you feel like you have I mean, there's definitely some intuition, but yeah, I would say your guessing seems to be paying off pretty well here. So I would definitely hold on to those intuitions.
Kind of thought 30%.
Yeah.
You still have to guess in your head.
You're kind of.
That's good though, I mean, I can't do
So we could think of it as 30% by 30%. I don't know if you can do that in your calculator.
I think it sends you to error.
Does it say error?
I think so, let's do it right now. 30% times 30%? Oh, it says 0.9. Okay, no, it does, it says 0.9.
0.9?
30 by 30%, yeah, 0.9.
That's not the answer though. 0.9 or 0.09?
0.09.
0.09, yes, that is the answer,
Yeah.
yes.
So you put a decimal point over, before you got your 9.
Yeah, yep, exactly. So remember that you can just multiply, if you have your GED calculator, you can multiply the 2 percentages together. Remember that they have to stay as percentages though, because of course, if you didn't do percent, 30 times 30 is 900. 900% probability is impossible. So that's always the thing, is trying to figure out, right? Okay, if I have 2 probabilities, once again, these are independent, right? The completion of project 1 early isn't gonna affect the completion of problem 2 early. If you wanted to look at it another way, right,
So you're telling me if I stand on the street asking for $30 a day for 9 days, I'll have $900? Or for 30 days?
No.
Right, it's 30 times 30. Oh no, yeah, it'd be $30 a day for 30 days to get 900. I'm sorry.
So as fractions, right, once again, you'd have 30, so, right, you still get 9 out of 100, which is 9%. If you think about it as decimals, it also works. So it's really just a matter of you have to figure out what those two probabilities are and multiply them together. And so here, right, 3 times 3 is 9, and then we have 1, 2 decimals, so 1 decimal. So yeah, so when you have compound probability and you're trying to figure out 2 or more events, definitely expect it to be a smaller likelihood because of course, as you can see, when we multiply fractions, decimals, or percents, right, they become smaller. And they don't get larger, so. All right, good warm-up problems, guys. Yeah, any final questions or concerns about probability or anything like that? Like I said, it's probably gonna be at least maybe 2 questions on GED math with probability, and hopefully it feels like one of those areas where now that we've kind of talked about it and, you know, kind of logicked our way through it, hopefully you feel like you can find the answers and stuff, so. Oops, I did not erase. Okay. All right. Oh, yeah. I was stuck in my favorite here. Oh. Okay. Um,
79 is what we were last on, but
Mhm.
it's,
but it's the answers to the
is
unit.
that what it is?
Yeah, that would be the answers to unit 3.
And then we're back to data analysis.
Yeah.
Oh no, the book keeps going. Oh no, the book keeps going, I'm just checking.
Hopefully there's still some more pages left.
83.
All right, you made it to our final unit of the semester. Even if we finish this up before June 12th or June, goodness gracious, December 12th, you know, we'll find other things as well to keep us going. And then going into the spring, I'm not sure what the math teachers are gonna decide to have us work on. We did algebra last spring, and I'm not sure if there's two, I know there's a few in the class, in the morning class that have been through a lot of the algebra stuff. Otherwise, we might do geometry, which is another nice complement to algebra. So anyway, I don't know, we'll figure it out, but
They still math.
yeah, I mean, yeah. Okay, let's go ahead and start our next unit. So similarly to probability, data analysis and working with data, interpreting both numerical and visually presented data is going to be not only crucial for the math test, but also science and social studies have a pretty good bit of maps and charts and diagrams and of course numerical pieces as well. So this unit should be applicable especially to those. Actually, even the language arts test has some tables. Probably wouldn't have to do any like math, but once again, being able to kind of interpret data visually is just a really helpful skill. And it's probably something that you kind of do automatically, But, okay. So this is page 83 in the bottom middle of the page. Hopefully everyone can find it. And so of course, most data starts by being organized into a table, okay? And so when we're talking about math, we're talking about tables, right? A table is usually a grid, right? And we have assigned some kind of meaning to the rows. And right, we put some kind of information into the columns. And so where rows and columns meet, kind of create a cell. If you're into making spreadsheets, which is pretty much all just making tables. Oh my God, my water right there. Oh yeah, I have tea. Oh, I should really do that. So here, so whenever you encounter a table, it's always just helpful to kind of do a survey and walk around it. Most tables are gonna have some kind of title, right? That's gonna give us the topic of the data that we have, right? So here we can see that the topic of this table is, right, US city population and the top 5 most populated cities. Okay. And so it looks like they're going to give us the population in 2 years. And then we're going to talk about how that affected their rank. Okay, in the final year. And then here we're calculating the percent change between the 2 years. Okay. And so hopefully everyone feels good and comfortable interpreting information in the table. Okay. So of course, data is only useful once we start organizing it and analyzing it. And so of course, even deciding what to collect and how and why is a huge piece of that. Okay. And so of course, tables generally are going to have a combination of words and numbers. Okay. And right, generally the rows and the columns are going to be labeled. Okay. Hopefully everyone feels comfortable when I refer to a row versus a column. Okay.
A row would be like Chicago all the way across, a column would be the 2000 population or the 2010 population, right?
Mm-hmm. Good. And what do these numbers signify? Were there only 2.89 people in Chicago in 2000?
It's millions.
Good. So that's another thing to always check is the scale. And of course, hopefully you would notice that this only applies to, right, these numbers, the population numbers. The rank is just first, second, third, fourth, fifth, right? And then percent is pretty obvious. Okay. When we have a percent change that's negative versus a percent change that's positive, what's the difference?
It's gonna be less.
Less when it's negative or when it's positive?
It's negative.
Good. So this we would call a percent decrease, right? So here we see that, right? Between these 2 years, Chicago was the only city that saw a decrease in population. All other 4 cities experienced an increase. So good. All right. So yeah, so we want to take a walk around the table. What's the title? We should get the topic. Okay, and then good. So we have our rows labeled and our column labels. Hi, Brandon. Good to see you. I'll send you the sign-in sheet.
Nice straight drawing.
Mm-hmm. So good. We always want to look for what, kind of like what units our numbers are being presented in, and then, yeah, so we get our. Sorry. And I'm sure you guys already know this, but I just want to go through it to make sure that everyone feels comfortable. Because of course, we're just gonna kind of keep building and building, so the more efficient we need to be at the beginning. In knowing how to kind of access and notice the important information that's gonna be critical. Oops, I can spell. Right, and then of course, the number part is our data, so mostly whenever we're creating a table, right, we're probably gonna use the first column to label the rows and the first row, right, to label the columns. And then when we input the data, once again, where our row and column meets, gives us like a specific point of data, okay? And the labels help us know that. Right? So always just be looking for that, right? What are they showing me? How are the numbers kind of, put together? What are my rows and what are my columns? Okay. Oops, sorry. Okay. So I think everyone feels good about finding information in the tables. And there are potentially going to be some problems that are going to be that straightforward. And those are the ones we should feel good about and will be quick and painless. Okay. Sometimes it really is just read the graph, but once again, they're probably going to be a little bit more on the complex side. They might be trying to sneak something funky in there, but you're right. So you might actually see a question, right? In 2000, the population of New York City was about how many times larger than the population of Houston. So it's not actually, sorry, that's not a good example, but sometimes it is just saying like, what was the population of Houston in 2000, right? The 1,950,000, right? But sometimes you're asked to compare. So you usually have to find two pieces of information in the table and then contrast them. If you need to figure out how many times larger, what is our operation?
Multiply?
We're saying how many times larger is it then?
Oh.
So it'd be dividing, right?
Yeah.
Your operation there, right? Because you're saying I have this bigger number and a smaller number, how many times bigger, right? So of course we would find that the value, so in 2000, there were 8.01 million people in New York City. If we compare that to 1.95 million in Houston, right, we divide. And here, since it's just asking about how many, and this is of course another thing about data and stuff, we can definitely estimate and round a lot more. And so, 8.01 is about 8. 1.95 is about 2. 8 divided by 2 is 4. So in 2000, right, the population of New York City was about 4 times larger. Okay.
We're just like rounding up on those numbers, right? Or
Yeah, what?
rounding to the closest 10.
Mm-hmm.
Okay.
Well, I mean, just round to the nearest whole number and then divide. If they said exactly how much larger, then we'd have to type in these exact numbers, right, and divide. So if we wanted to find the exact figure, 8.01 So yeah, it's actually a little more than 4, right? 4.1. 4.1 times larger. So yeah, if you need to figure out how many times larger, you're gonna be dividing. Divide the big number into the smaller number, okay? Does everyone feel good about example 2? Okay, so
Yes.
another useful thing about tables is that once again, the tables help us draw conclusions, okay? And so once again, if we looked at this data,
You see a big 23 times 3
yeah.
on the data.
There we go. No worries. Right, hopefully you would notice right away, like, oh, right, this is the only one that is negative. All the other cities increased in population. Philadelphia had the smallest increase, right? Houston had the largest increase. And Chicago decreased. So you can kind of draw conclusions, you can make statements, right? What was happening in those 10 years that a bunch of people left Chicago? I don't know, murders is usually what
Yeah,
they say is happening.
Chicago's really chaotic.
Mhm.
Really not a good place to be.
And so, right, we could conclude that, the populations primarily increased in the largest cities in the US, okay? All right, so go ahead and try problems 1 and 2 at the top of page 84 using this table here. I'm gonna go finally get my tea and I'll be right back, okay? Let me know when you think you have your answers, or if you're on Zoom, you can type your answers and put them in the chat. But I'll be right back. Okay, we need 2 minutes more. Okay. Like that number, George. Okay. Thanks for sharing. We'll see how everyone else does here. What's that? Oh. Actually, I guess you're not on figure out. Let me figure out where to go on. All right, Victoria. Victoria, you found the difference in prices of the original price, but I think they want the
30.
sales price. What?
30 bucks. 25% off at $120.
Mm-hmm. Okay,
$90.
and then what's the sales price on the, speaker?
Speaker $68. 15% of 80. Taken off.
Okay. And then 90. Okay.
It's great. Two.
Okay. So 90 minus 68 is 22, like George said. Does everyone remember how to calculate a sales price? How are you calculating it?
On this calculator.
Okay, good. That's perfectly fine. And then what's the sales price of the TV?
Sales price of TV is $184.
Thank you. Okay. Okay, so hopefully everyone's seeing, so 90 minus 68, I think, yeah, 22, yeah. Right, so the portable speaker and a DVD player, so yeah, the only thing that was funky on that one, and I did the same thing, Victoria, and I shouldn't have made you guys think they were gonna be easy, because I guess they're not, which is good for us. But yeah, so on Saturday is assuming, right, that you have applied the discount and are selling at a different rate. So then if we take 90 minus 68, the price difference is $22, which is not very useful information in my opinion, but whatever. Wow, I can't spell. Okay, And then everyone agreed that, right, the actual discount, right, the money being taken off or subtracted off is, right, the actual discount in dollars on the TV is greater than the actual dollar discount on the, greater than fine. Um, okay. All right, and is everyone, so yeah, right, there's a $30 difference here. And then what, like a $46 difference here?
48.
$48 difference, sorry, thank you.
Sorry, I became a little too strong.
No, it should be 46. 230 minus 184.
Yeah, I'll say it again.
It's
Probably get 48.
typed wrong.
Maybe.
You saving 46 bucks. Yeah,
Yeah. And that is a greater actual discount, right? Even though,
great.
right, the discount rate is higher on the DVD player because the TV's price is more and the discount isn't really that much smaller. Yeah. Yep, so there's definitely, hopefully you guys are starting to kind of put on that dual mindset of, what's my situation? What do I know about it? And how does that help me kind of logic through some of these things? All right, everyone feeling good about reading tables, or do you want to do a couple more? All right. Anyone? Continue? More?
Yeah.
All right. Go ahead and go down to the bottom of page 84 and just use 7 and 8. And you could do 3 through 6 for homework, but just work on 7 and 8. Hopefully the mileage chart makes sense, right? So basically we're saying how many miles is it, right, from Mexico City to Montreal, right? And that would be 2,312. Of course, the blanks are where the same, right, the row and the column are the same. So of course there's 0 miles between Mexico City and Mexico City. Oh, and that's the answer number 8. Damn it. Sorry. I ruined it. Too helpful. Let me know when you got your answer to number 7. Okay. George says 4,449. Do y'all agree?
4,000? I got 3,449.
I
I got 3,449.
Okay.
Not 4,449.
Okay.
Well, it's because you're taking the 1,883 back down to New York, which is 2,566. So you just put those together, right? That's how I did it.
So 1,833 plus 2,566.
Yeah, is that right? That's how I was gonna do it.
No, because he said to New
I just
York.
didn't do the adding part.
So you would Mexico to San Francisco and then down here, San Francisco to New York.
Oh, I know what I did. Okay, if you guys did it that way, I did it the other way. I put from San Francisco back from New York all the way down to San Francisco at the end. You see what I did there?
You added a leg to the trip?
Cause you're gonna land in San Francisco, so you jump down here to San Francisco. And then you're flying to New York, right?
Mm-hmm.
It should be the same. Yeah, no. It's 3,449. Put it in. It's
No, I'm
3,449.
giving 4.
No.
1,400.
Right, you're adding this number
1,883
and this number.
plus 2,556.
2,566.
You know what I did? Instead of putting a 2, I put a 1. Look. I put 1,566. Oh, no, I would have been on if I didn't put 1.
Good. All right. Yeah, Victoria, I don't know if you had a calculation entry error on yours, but hopefully you guys found the 2 numbers, right? So yeah, our first leg, Mexico City to San Francisco, plus our leg from San Francisco to New York. And so a combined 4,449 miles.
So I was on the right page. I just put the wrong number.
Yes, you just can't type stuff into your calculator very well.
I'm very
So
dyslexic.
fix that.
On 8, I didn't put that.
That's okay. What did you put? I'd love to hear your answer.
It's a smart ass answer.
Yeah,
Okay.
no, that's how I kind of got out of it too.
Yeah,
I just put can't fly where you already are.
yeah, not really. You could
Yeah,
maybe
that's it.
take a helicopter tour of the city or something like that, but yep, exactly.
That's a pretty smart answer.
Cause I doubt you could even even though like New York has 2,
Yeah, there's JFK in New York.
and LaGuardia too. LaGuardia, I think is where it's out of. Okay, good, Victoria. Hopefully you at least were reading and accessing the information. So reading a table, hopefully it doesn't feel too hard or confusing for anyone. But yeah, right, because basically, right, our row labels and our column labels are the same, we're always gonna have that one cell, right, where they meet. And if we're talking about a distance chart or a mileage chart, yeah, it's like, can't fly somewhere where you're already at, right?
Man, where's your restaurant?
You may, you could even walk, I don't know how urgent. Okay. So once we have gathered and organized our data into a table, generally the next step that a lot of the research analysts or researchers or people who work with data do is then figure out how to visually represent this data. And so graphs are generally the way that we do this. And there are different types of graphs. And so that's what we're gonna begin to kind of dig into. And so, like I said, generally you start with a table and then you would, right, based on the data you collected, you would choose a graph that's going to help represent that. So we're going to start with bar graphs, and we're going to start with another type of graph called a histogram. Has anyone ever heard of a histogram? Yeah. Okay, good. All right. So bar graphs. Okay. So yeah. So if we want to have a visual picture of our data, because sometimes, right, and especially if we have a lot, right, if we had You know, if we had like 20 more rows of numbers here,
Yeah.
it would be really annoying to have to try and like comb through all that. That's why computers do that, right, for us generally. Okay, so our first type of graph, a bar graph. Okay, data is represented by the height or length of the data bars. Okay, and the bars may be drawn vertically or horizontally. So this is right vertical where our bars go up and down, but you could have a horizontal like this, right, where your bars go right and left. Okay. So for the bar graph below, once again, similar to our table, we can expect titles that tell us exactly what this data represents. And then in at least a bar graph, we're gonna kind of have rows and columns as well. We're gonna have, right, our rows are gonna kind of represent our numerical values, and then right vertically is how we're creating our bars, and then we're labeling each bar right on the horizontal. Okay. So we still have a title and labels. They look a little bit different, but they should be there, and they should, once again, right, tell us all the information we need to know. So bar graphs are drawn, right, with an axis, right? So once again, this is our horizontal.
I see mac and cheese and chicken fingers. I'm thinking KFC because I have both.
Yeah, that is true. That's kind of like that. Mac and chicken cheese fingers.
Mm-hmm.
And grilled turkey cheese sandwich, which actually doesn't come with that. And then the pork and the vertical, okay, so good. And so, the labels, right, help us know. So we're talking number of high school cafeteria orders, for, I guess, just a couple days here. That's kind of weird, like a week, I guess, a week. And right, we counted the number of types of food ordered, okay? And so, hopefully you would agree that, right, when we just kind of visually assess this, what lunch is the most popular? What meal is the
Pizza.
most popular? How do you know that?
It's the
Yeah.
biggest bar on there.
Right, tallest is always most, right? And therefore we know that shortest is always gonna be the least. Yeah, it looks like turkey sandwiches. Down at the bottom.
No, turkey sandwich is not bad sometimes.
Yeah, like I said, I'm not gonna feel like I don't have a lot of like food preferences. If it's free and prepared, then I'm down.
Hell yeah.
Yeah, I know. I'm like hot, fresh
But no,
food.
it's true though, it's true.
Yeah.
See, at work, if I get hungry, I can just toss a sandwich in the oven because it's already made, you just gotta heat it up.
All right. So hopefully everyone feels good about reading a bar graph. If we needed to come up with the exact number, right, we basically just kind of draw the line. Actually, probably an actual line and maybe it'd be a little bit better. Right, to kind of help you. And you can do this on the GED testing screen, I'm pretty sure. But just kind of just kind of helps you read the graph. And so, right, if we look at pizza, it's about 282, I guess, because it looks like we have, right? The other thing you want to look at is your, what do we call that? Actually, I can't remember.
The little lines.
I thought it was going by cents and five.
Yeah, that's what I'm talking about, going by, I think it's by twos, right, or by
Fives.
five. Oh,
Yeah, because they're only going center, it looks like.
this would be 212, 214, 216.
Yeah, it's going by
218.
two,
Yeah.
210, 11, 12.
Yeah,
Oh, snap.
it's like the increment. Yeah, it's pretty small. No worries, no worries. And once again, usually with a bar graph, if they wanted to be exact, sometimes they'll like put the exact total like at the top of the bars. It's usually like an option if you've ever built bar graphs, like in Word. But good. So reading the bar graph, hopefully everyone feels good about that. Then we'll probably layer on, right, reading 2 bars, comparing, contrasting in some way. Okay. But good. And so you may need to estimate the values. And so, yeah, it's not exact, but I guess you can, how about the increments of the scale? The scale. Oh, don't bother me. You don't remember it in the middle of the night. All right, so just really fast, if we use the bar graph up here, which meal option sold over 250? Only pizza?
And grilled cheese. Pizza, grilled cheese,
Even
and
like mac and cheese, yes.
mac and cheese is like a little bit over.
Yeah, so mac and cheese, pizza, and grilled cheese, right? And so once again, you could just take your line, right, and basically start at your 250 and just, right? And anything that's above that line, right, is over 250. So make myself hungry. Grilled. Grilled cheese. Almost made myself grilled cheese.
Do you remember how I spelled cheese?
C-H-E-Z. No?
CHESSE.
Oh. C-E-S-O. How many more orders were for pizza than lasagna?
Roughly about. What's going up right there?
40? George says
40.
about 40?
Mhm, 40
Yeah.
is good.
Yeah, and 42 would be the accurate. It does say about how many in the problem. So we could probably just estimate or round.
I think for just.
So about 40, but probably 42 exactly, yeah. So that is gonna be, you know, one thing to make sure is like, do they want the kind of the estimate? And some, if it's multiple choice, you could probably see that, right? But,
Well, it's supposed to be a nice school if they're giving you lasagna, pizza, grilled cheese.
I know you get 6 choices for lunch.
Right?
Sounds nice, yeah. I was like, man, do we, I don't even think we had mac and cheese. We had none, not fingers. Okay.
I got a packed sandwich with a bag of chips that went stale and chucked it being in a lunchbox for like 6 hours.
Okay, so of course, sometimes we might have, right, bars that are 2 bars that have the same label. And then oftentimes, and this is gonna be a little bit of a challenge, but hopefully everyone feels like you can read this okay with the scanning. But if it's helpful to like color a bar, okay? So when we have 2 bars with the same label, but they're shaded differently, right? Then we would see the bars themselves kind of get their own label here, right? And then our horizontal axis is telling us profits, right, in dollars. And so what's the point of having the 2 bars? What does that help us do or see?
Well, if you look at the problem, you know, like usually if you look at 3, making year 1 and year 2, you can tell which one is the one you're looking at, which is the one you want to see.
But what are the 2 bars? What is the difference in the information between the 2 bars? And why is there 2 bars with the same label?
It's comparing one year from another.
That's
To
what
show a difference. Oh, and maybe that's what you were saying, Nick. I'm sorry.
I'm bad at explaining.
Thank you, Chrislyn and Jordan and Alyssa. Yeah, so so yeah, we know that the top bar is year one's profits. Bar two is year two's profits, and by creating this double bar graph, right, it allows us to make those comparisons easily and quickly. Okay.
Well, it looks like you get 25,500
For
first year.
So it'd actually be 1,500.
how much more profit did the petting zoo
No, I'm saying
make
that's what they made.
in year two? So it looks like they made
Year one.
1,500 more. Pardon?
Yeah, year one. Year one, they made 2,500, right?
Yep. Yep. And remember that each, like this chunk here, right, is $1,000.
Or if you look how they divided it,
2,000.
they kind of put it in like the halves where you can see,
Mhm.
at least for the top, the games and food booths are kind of like
Yeah, but it looks like we do have
a
quarters.
couple
Yeah.
hundred over yet. But for the two middle ones, they're like cut 50-50.
So which events experienced a decrease? Or which event experienced a decrease in profits? Auction, right? We know that because the bottom bar is shorter, right? Whereas the other three, right, the bottom bar is longer. Good. So let me,
I was thinking auctions as in stocks for some reason. I just realized that now.
I mean, at a family fun carnival, I'm assuming you would auction off farm animals. I don't know what it's
Unless
like.
you're
in
doing like
Arizona.
4-H or something.
Yeah. I mean, I guess we could, and then we would say that the auction. The auction. What about number 5? Year one, about how much more money did the auction make than the food booths? So here we only care about the top bar, right?
Like 3,100.
Because yeah, we got about, I would say 3,000.
Well, it's like
Yeah,
a little over the
2,100.
two. Yeah, like I want to say about like 30.
About how much more? Yeah. So Victoria, I think you're very precise there. 2,900. Well, it's okay because it's asking about how many, and for me, right, if I look at auction year one, that's about 5,000. Food booth year one's about 2,000, so.
Oh, I looked at the year two. That's why I got 2,500.
Yeah, so read the questions carefully, right, and remember, the question will kind of, focus, right, where you need to. So if it's only talking about year one, you don't care about the bottom bars. Okay, if we're talking about year one versus year two, then we might be looking at one cluster or multiple. So which events profits increase the most?
Petting zoo.
Okay. How do you know that?
Well, if you look at games year one versus year two, it's only like $500 more. And then if you move down, you have the decrease, and you have like in year two, like $200 profit. So if you get petting zoo though, you have like 1,500 profit. Also, you can kind of just tell off the bars. How I look at it, I'm a visual person. I just kind of visualize the bars and see which one is.
And that's what's a nice thing when we get into this data analysis and the scrap stuff is there's generally a pretty clear numerical way to kind of work with it, but there's definitely visual ways, and we'll probably be doing more estimation than exact because kind of like with probability, we're already making a prediction. We're already trying to kind of guess the likelihood of something. So rounding, estimating isn't really gonna affect that too much, I don't think. Other times being precise is absolutely important. So yeah, you could just visually assess, right? That basically, right, the part of the petting zoo that sticks out, right? There's more of it. And once again, we know that these lines here, right, represent 1,000, and none of the other ones that gain or that had increases from year 1 to year 2, right, are as long or, right, as things. So, good. Okay, everyone feeling good about bar graphs? Shouldn't be too crazy of information. So let's see, it's 6:24. Really fast, we'll touch on histograms, but we'll probably come back to this on Monday, okay? So a histogram is another type of graph, and it's going to use data bars, okay? And one thing I want you to notice, and this is at least the way my brain works, when the bars are smushed together, it's a histogram. When the bars are separated, right, it's just a bar graph, okay? So visually, to recognize a histogram, if it looks like the bars are smushed together, and especially tall in the middle, generally is what you're gonna see for the most part, then you're looking at a histogram and not a bar graph, okay? So on a bar graph, the bars represent different categories. On a histogram, the bars represent a range of numbers. So, if we look here, we were collecting, we were just making like a tally mark, right? Mac and cheese 1, the chicken fingers 1, right? We're just counting each thing in its category, okay? Instead, with histograms, we're going to count kind of the number of people that gave an answer within a certain range, okay? And we'll see this here in a second. And a histogram helps us draw conclusions about frequency, okay? And so kind of similar to probability, a histogram shows us kind of how, like, where's the most likely scenario lying, okay? So, oh yeah, interval, that was the word I was looking for earlier. The interval, right, between the numbers on your axis. There we go. Okay, I feel better. Hopefully again good. So each bar on the histogram below represents an interval. Okay, so right, this first bar represents any data between 5 and 9. Okay. And so here, if we look at the histogram, okay, so we use the vertical axis, tells us how many cars are sold. And then here's, right, so we have a range of cars that we're selling, and right, we're kind of organizing the cars based on fuel efficiency. So we have cars that get about 5 to 9 miles per gallon, right? 4 of the cars sold get 10 to 14 miles per gallon. So do you see how the bar is in between and representing this interval of values? So if it was 6, I would count it in this category. If it was 7, but if it was 11, right, I wouldn't count it in that category, okay? And so, how many cars were sold in April with an estimated gas mileage of less than 15? So that would be, right, these 2 bars here represent less than 15, and everything over here is more, okay? And so this histogram shows us that, right, that the majority of the cars that they sell have between 25 and 26, right, miles per gallon, okay?
Which is not bad.
No, not awful.
I would like to see 45 miles to a gallon though.
Yeah, that's our upper limit. Does everyone kind of see how the histogram looks different? And so we'll get into this. If you want to finish the problems on page 86, to prepare for class on Wednesday, or sorry, next Monday, you can. But if not, we'll just pick it up here on page 86 on Monday, okay? And like I said, go back if you want and do 3 through 6 as well on page 84. Okay? If you feel like you need more work with the tables. hopefully you guys are noticing everything that we're touching on this semester, right? It's really about noticing and reading carefully so you know what to pay attention to so that you can find that and then kind of putting it together. So, all right, awesome work tonight, guys. Hopefully I'll be back to 100%. I wanted to ask you guys on Zoom, did anyone on Zoom, I did get a few more math books printed up. Did anyone, is anyone new who needs a copy? Otherwise, Brandon, I've already sent you this one, but I just want to make sure. Like
I can
Crystal
come in
and-
tomorrow and pick one up. I actually
Okay.
need one.
Okay. Cool. They're in the classroom right now, Kayla, so when you come, if I'm not there, just let the Linda or Daniel know that they're in the classroom.
Okay, thank you.
Yeah. All right, take care, guys.
Have a good night, Julie.
Thank you. There's not a language arts packet, Celeste, but I have printed out the new, thank you, Darren, the newest language arts unit. We started unit 5, I think, last Thursday. Alyssa, you think you have any time to start a progress test anytime soon? Tomorrow. Okay. Well, could you come tomorrow at like 3:00? Okay. I will look for you then. If not, we'll figure it out.
Alright.
Okay. Oh, you need me to send it to you, Celeste? The language arts materials? Okay, I can do that.
Maybe is there any chance I could go for another social study like practice, if that's possible?
Okay. Yes, it is software.
Would it be for language arts
Pardon?
or math?
The progress test is like the placement test you did during orientation, so,
Would it be both language arts and math? Oh,
but like I said, tomorrow we can just do one subject and then set a time for the next one if you just want to do one tomorrow.
Okay.
Just getting you started will be hopefully satisfy the people who